Hello everyone, welcome back. Today I'm going to be talking about chemical reactions. So what are chemical reactions? Obviously, they are reactions that occur between chemicals, but they actually occur when these chemical bonds are formed, maybe they're rearranged or broken. And I'm also sure you've heard of the word metabolism. People throw that word around a lot. But metabolism is actually when all the chemical reactions in our body are occurring. And chemical reactions, we write them in the form of chemical equations. Even though this is not chemistry, you still have to know these terms. So we're going to have reactants and products. These two make up a chemical reactions. So reactants are basically the substances, the molecules going into the reactions that you're putting together. So if you want to bake a cake, the flour, the milk, the eggs, those will be the reactants. And then the product are going to be the end result, the stuff you get at the end of the chemical reaction. So we now call that cake. When you're eating cake and someone asks you, what are you eating? You're not going to say, I'm eating some eggs, some flour, some milk. No, you're just going to say cake. So cake will be the example of a product. So here I have examples of what a reactant is and what a product is. So for example, hydrogen plus hydrogen would give us hydrogen gas. Or, we can also have 4 molecules of hydrogen and 1 carbon atom. And together we call it methane, right? We call it methane. So there are 4 types of chemical reactions: synthesis reaction, decomposition reaction, exchange reaction, and reversible reaction. So I'm going to go over all of them. So when you think of synthesis, another word for synthesis is making. We're making something. So it's just a fancy word for making. So anytime you see the word synthesis, making, think making. So it's no surprise that in synthesis reaction, you're going to think of addition. If you're making something, if you're going to make something, what are you thinking? Again, going back to the cake, you're going to mix the flour with the eggs, with the milk. Everything has to be mixed together, right? So addition. And the example I have here is A plus B equals AB. We're not going to say, just A plus B again. We just say, like, for example, cake. So again, like I said, use an anabolic or building up of processes. So how is this applicable in the human body? So when you are eating food, you're eating, your breakfast, your lunch, your dinner, all those, salads and fruits you're eating, your cells are using that to build up bones and muscles and skin cells and hair, right? So that, again, goes back to building up, making of stuff in your body. The opposite of that would be decomposition. Decomposition, you're thinking decay, breaking down. So think breakdown. And here we're going to take this AB and we're going to break it down to A and B. And how is this applicable in your body? Where when you're done eating all the food, right, the waste products will be an example of decomposition. Another way would be when you're exercising. When you're exercising, you're burning fat, right? So that would be an example of decomposition reactions, which we use in catabolic. Catabolic means breakdown, by the way. The other reaction would be exchange reaction. So this is a combination of synthesis and decomposition reaction. And I have the example here as AB plus CD equals AD plus CB. So we can see, everything just kind of got moved around a little bit. And the last one would be reversible reaction. And reversible reaction, meaning we can go from A plus B to AB. An example of that would be water. So let's take you have water and ice. You can freeze it to become, a bigger amount of ice. And then when you want to get your water back, you can just kind of dissolve it and you will get the same thing back. So that would be an example. So in the human body, we refer to these reactions as a redox reaction. Redox is short for reduction-oxidation. So going back to the molecules, going back to chemical bonds and so on in the previous videos, we saw that atoms are reduced when they gain electrons, when they lose electrons, right? We use the word oxidize when they lose electrons. Again, atoms are reduced when they gain electrons, and atoms are oxidized when they lose electrons. And here I have an example, C6H12O6, which is glucose. That's actually the chemical name for glucose, and oxygen, which is obviously O2, but we have 6 molecules of that. So when you now use oxygen and you combine oxygen and glucose, you break that down, and what you end up getting is carbon dioxide, water, and energy. You know, we all know glucose gives you energy. So this is where that energy, ATP, is coming from. I'm going to be discussing ATP later on. ATP is short for adenosine triphosphate. All right. So this is what we call energy in the human body. So here we see that glucose is oxidized and oxygen molecule is reduced. So I want to talk about the flow of energy and chemical reactions. Flow of energy. So I have here people exercising, working out. So we're going to see some reactions are going to be exergonic reactions. You're releasing energy when you're walking, you're running, you're exercises, you're giving off energy, you're breaking down stuff, right? Which is, again, going back to the catabolic reactions. And endergonic, you know, when you're famished, you're starving, you need to build up all these proteins, the good ones, so you're going to eat, right? You take in or use up energy. Again, this is going to be an example of anabolic reaction. So this is just like an introduction. I'm still going to talk about, you know, what really happens in terms of the rate of chemical reactions, but the speed of chemical reactions can be affected by temperature, concentration, and size. So for temperature, the higher temperatures increase the rate of reaction. So higher temperatures will increase the rate of these chemical reactions. So concentration, increased concentration can also increase rate. What do I mean concentration? So if you have more of something, then that means that the rate of the reaction will also increase. And the size, the smaller the size, the faster the rate, right? If you ate a little bit amount of food, that will obviously be digested faster than if you had a whole lot of food. And catalysts, you know, I'm going to be talking about catalysts again in the next video. So catalysts are what we use to basically speed up a reaction. And they do this by increasing the rate of the reaction without changing or becoming the product. And a great example of that will be enzymes. So again, like I said, I'm going to have another video where I'll be talking about catalysts, enzymes, and substrate, and so on. So that is going to be the end of today's video. Thank you.